people are going to fall through the ceiling when I hear those noises. All right, negative 5/6. For anyone who stumbled upon this video and isn't a Phoenix person, we have construction going on literally above us. It's a little bit nerve-wracking. All right, so dude, where this problem is way harder than like a normal just like 3x is if we for a moment think about those situations where like you have like 3x equals 18, what we say is, oh, x is multiplied by 3. What we do to get rid of it is divide by 3, and that's relatively easy compared to what we're trying to do now, right? X would become 6, and we're all good to go. But that's not the situation we have here. We have a fraction times our variable. So again, we think about we want 1 times our variable, right? What we want, what we always want, is 1 times the variable, which in this case is x. So what we ask ourselves is, okay, how? Well, over here, dividing by 3 is how we get 1 of our variable, right? But over here, we have a fraction times the variable. So we remember the rule that a fraction times its reciprocal is equal to 1. And that is such a convenient rule to remember because it works all the time no matter what. So the reciprocal of negative 5/6, we just flip it. Now I'm going to rewrite this so I have a little bit more space. So this is just me rewriting the problem again so I have more space. So the reciprocal, I'm going to write this in green since I wrote that note up there in green. The reciprocal, we flip it, and we put the 6 on top now, and the negative 5 on bottom, and we do it on both sides. 6 on top, negative 5 on bottom. This, on the left-hand side, will actually get us negative 30 over negative 30. As we get comfortable with that, we can go ahead and say, when we're multiplying a fraction times its reciprocal, it all just kind of disappears, because it really becomes 1x when this, right, number over itself, when that becomes 1, we really just get 1x on the left-hand side. Now we need to do the right-hand side. Negative 10 times 6, negative 60. 3 times negative 5, negative 15. Now we start thinking about simplifying or reducing, so I'm going to drop this down to do that. But when I'm dropping it down, I can actually do one part of simplifying. What happens when we have a negative over a negative, or a negative divided by a negative? Positive, yeah, so this really, I can get rid of those negatives and just say 16 over 50. And then again, we see ends in 0, ends in 5. So we know when we end in 0, end in 5, we can divide by 5. Oh, no, I drew that arrow way too big. So if we divide by 5, 60 divided by 5 is 12. 15 divided by 5 is 3. I think we can reduce again. What can 12 and 3 both reduce by? Or both divide by? What can 3 divide by? And can 12 divide by 3? Yeah, so since 3 can divide by 3 and so can 12, that's what we're going to do. And we end up with 4 over 1, which is really just 4. Right, so we can now say x is as cleaned up and reduced as possible. X is 4. So again, just to review what we did, we had a fraction times the variable. The easiest way to turn that into 1 times the variable is to use reciprocal multiplication. So we multiply by the reciprocal of the fraction we want to get rid of, and we do that on both sides. That helps us get rid of that fraction over here and turn it into 1. Once we've done this multiplication over here, we have to reduce it by dividing by a common factor, and we actually end up doing that reduction twice. Now, a way we could have avoided reducing twice, if you are at home yelling at the camera, is we could have said, or sorry, yelling at the video, we can divide this by 15, and actually we can do that on the top as well, and that would have jumped us to 4/1. That's another way we could have reduced. We don't have to, because we divided by 5 and then divided by 3. It did the same thing, but that's another way if you're really thinking about those bigger common factors.